Imagine waking up tomorrow and finding that your smartphone won't turn on, your internet has stopped working, your car won't start, hospitals can't operate their medical equipment, ATMs are offline, and even your TV and refrigerator have stopped functioning. Sounds like a science fiction movie, right? But there's one tiny invention whose absence could make all of this a reality: the semiconductor chip. These microscopic chips are often called the brain of modern electronics. Today, let's discover why semiconductors are among the most important inventions in human history. So, what exactly is a semiconductor? A semiconductor is a material that conducts electricity only under specific conditions. It behaves somewhere between a conductor like copper and an insulator like rubber. The most widely used semiconductor is silicon, extracted from ordinary sand. Scientists use advanced manufacturing techniques to transform silicon into tiny chips containing billions of transistors. These transistors act like microscopic switches that process, store, and transmit information at incredible speeds. Think of a semiconductor chip as the brain that controls electronic devices. Now let's see how semiconductors are involved in almost every moment of your day. When you wake up, your smartphone's alarm rings because semiconductor chips control its processor, memory, display, and sensors. While preparing breakfast, your microwave oven, coffee machine, and refrigerator all depend on semiconductor-based control systems. Traveling to work or college? Modern cars contain hundreds or even thousands of semiconductor chips that manage engine performance and braking systems. Even your smartphone, wireless earbuds, digital camera, and gaming console owe their intelligence to semiconductor chips. The future is even more exciting. Artificial intelligence, robotics, autonomous vehicles, and the Internet of Things all require powerful semiconductor chips. Every AI tool that answers your questions or generates images performs billions of calculations using advanced semiconductor processes. Simply put, there is no AI revolution without semiconductors. Today, semiconductors have become more than just electronic components, they are a matter of economic growth and national security. Countries like the United States, India, Japan, South Korea, and European nations are investing billions of dollars to strengthen semiconductor manufacturing. Why? Because the nation that designs and manufactures semiconductor chips gains technological leadership, stronger industries, better jobs, and greater strategic independence. That's why semiconductors are often called the new oil of the digital economy. If making chips were easy, every country would manufacture them. But semiconductor manufacturing is among the most complex industrial processes ever created. Building a single semiconductor fabrication plant, or fab, can cost over $20 billion. Manufacturing involves ultra-pure silicon, thousands of precision manufacturing steps, atomic-level engineering, dust-free clean rooms, extremely advanced lithography machines. Even a tiny particle of dust can ruin an entire chip. Only a handful of countries possess the expertise required to manufacture the world's most advanced semiconductors. If there is one place that sits at the heart of the global semiconductor industry, it is Taiwan. The island manufactures a majority of the world's advanced semiconductor chips. Companies from around the world, including Apple, Nvidia, AMD, Qualcomm, and many others, depend on Taiwanese factories. This makes Taiwan strategically important far beyond its size. Any disruption caused by conflict, natural disasters, or political tensions could create severe shortages of chips, affecting industries across the globe. That is why Taiwan has become one of the most geopolitically sensitive regions in the world. The high geographic concentration of semiconductor manufacturing and its dependence on a few critical raw materials make the global semiconductor supply chain vulnerable to geopolitical conflicts, trade restrictions, and natural disasters. The geopolitical significance of this concentrated supply chain became evident following the Russia-Ukraine conflict. The electronics industry faced a severe semiconductor shortage after the disruption of neon gas supplies from Ukraine, a critical input in chip manufacturing. Another geopolitical dimension is US-China technology rivalry, the chip war. While the United States seeks to maintain leadership in advanced semiconductor technology, China aims to reduce dependence on foreign suppliers. It is evident by the fact that the United States has imposed export controls restricting China's access to advanced AI chips and semiconductor manufacturing equipment. To counter the United States, China has increasingly used its dominance over mining of critical minerals as a geopolitical tool. China has imposed export controls on supply of critical minerals such as gallium, germanium and antimony, materials that are indispensable for manufacturing semiconductors. Furthermore, the latest dimension of semiconductor geopolitics is the semiconductor subsidy race. Countries across the world are investing billions of dollars to expand domestic semiconductor manufacturing, recognizing that these tiny chips power transformative technologies such as artificial intelligence, AI, quantum computing, 6G communications, advanced robotics, autonomous vehicles, and other innovations that will shape the future. The United States enacted the Chips and Science Act to support semiconductor research. The European Union launched the European Chips Act to strengthen domestic production. India has introduced incentive programs under the India Semiconductor Mission to attract chip fabrication investments. Moreover, there is an emerging trend of friends-hoing which involve countries shifting their manufacturing and supply chains to allied nations with shared political and economic values. This strategy reduces systemic risks from geopolitical rivals. For example, countries are forming strategic alliances like the Minerals Security Partnership to secure critical minerals such as lithium and cobalt from trusted suppliers like Australia and Canada, ensuring resilient semiconductor supply chains. Looking ahead, emerging technologies such as quantum computing are expected to create new demand for even more sophisticated semiconductor architectures. AI is transforming the semiconductor industry and redefining the requirements of modern computing. Rather than relying on general-purpose processors, companies are increasingly adopting AI-focused chips, including graphics processing units, GPUs, specialized AI accelerators, and high-performance memory, to support the intensive computational demands of machine learning and generative AI. At the same time, the rapid growth of electric and autonomous vehicles is driving demand for advanced logic chips to power AI-based driving systems, power semiconductors for battery management, and connectivity chips that enable vehicle-to-cloud communication. This has prompted countries like USA to resort to export controls, investment restrictions, and technology partnerships, reflecting a broader strategic competition for leadership in AI and semiconductor technologies. Initiatives such as Pax Silica, a United States-led framework to secure supply chains for semiconductors, AI, and critical minerals, illustrate this trend by strengthening cooperation among like-minded countries while reducing dependence on China for critical technologies. Despite all this geopolitics surrounding semiconductor chips, according to global assessments such as the Forrester Global Sovereignty Forecast, achieving complete technological sovereignty remains difficult for most countries because semiconductor supply chains are deeply interconnected globally. A single semiconductor chip may cross international borders multiple times during its design, fabrication, packaging, testing, and assembly. Consequently, in 2026, technological sovereignty is increasingly defined not by complete self-sufficiency but by strategic resilience. Countries seek to develop sufficient domestic capabilities in critical segments of the semiconductor value chain so that no single geopolitical rival can disrupt their digital infrastructure, defense systems, automotive industry, or other strategic sectors. Since semiconductors have emerged as the new strategic currency of the 21st century, the long-term objective should not be absolute technological sovereignty but secure, resilient, and diversified semiconductor ecosystems that balance global cooperation with national security.